Welcome. So in this lesson, we're going to begin by talking about complementary properties. Before we launch into the notes, I just want to work through this little PowerPoint with you just to give you a bit of an understanding of what we'll be doing. So let's begin. We've already seen symmetry properties before. Previously, we spoke about supplementary properties. Supplementary meaning add up to 180 degrees. So that's when we were talking about pi plus or minus some angle, pi being 180 degrees, and of course the multiples of it as well. So 2 pi plus some angle, 2 pi being 360 degrees. And we learned that there were properties for each quadrant, which we have memorized. So what we're now going to learn about is not supplementary anymore, but complementary properties. Complementary meaning adds up to 90 degrees. So that's pi on 2 plus or minus some angle, pi on 2 being 90 degrees. And also we're going to be learning about its multiples as well. So for instance, 3 pi on 2 plus or minus some angle. And just as there were properties for each of the supplementary properties for each quadrant, so too for the complementary ones. Now we're going to have to write all of these down, but before we do that, I just want to actually show you where these come from and what they mean. And by doing that, we're actually going to learn where the names sine and cos come from. Here is the sine graph in all of its glory. Here is the sine graph right here. We've seen it plenty of times before. I'm going to do something interesting to it. I'm going to take it and I'm going to move it back pi on 2 or 90 degrees. So I'm going to take the sine graph and I'm going to translate it back pi on 2 degrees. And I want you to see what happens. And I want you to see what it looks like after we've done this translation. So you're ready? We're going to take it, we're going to move it back pi on 2 or 90 degrees. Here we go. What does that look like now? And hopefully you're all saying that looks like the cos graph, doesn't it? It looks like the cos graph. And sure enough, it does. And this really comes from where these names come from now. So we're actually going to learn where does sine and cos come from, because this is very much tied up with it. So sine is an abbreviation for sine, just with an E here, and the etymology of it just comes from the word curve. So no big surprises there. It just comes from the word curve. Cos, on the other hand, comes from the word cosine, and this co at the beginning means complement. So this means the complement of sine. So these are where this word comes from. So co means cosine, which means the complement of sine. So what exactly does that mean? So if I have sine of 60 degrees, I know that's going to be equal to the complement of sine. Complement means adds up to 90 degrees. So 60, what would its complementary angle be? It would be 30, right? So that means that sine of 60 is going to be equal to the cos of 30. And sure enough, the sine of 60 is the square root of 3 on 2, and cos of 30 is the square root of 3 on 2. So that's where it comes from. So we can get this definition here that the sine of an angle is equal to the cos of its complement. And that's where it comes from. And that's how we're going to be, this background information is what we're going to be using to figure out some more properties of the unit circle and all this great stuff. So let's now go through this, and you're going to write in certain values into your notes here. And when they come up, I'll tell you what you're going to write down. But let's look at this for a second. So here I've just chosen pi on 6. And if I ask you what is cos of pi on 6, you would know that it's just the square root of 3 on 2. It's just this x value right here, the square root of 3 on 2. Well, what if I now take the complement, find the complement of pi on 6? So obviously it's going to be pi on 3. So it will be this blue angle right here. So it's pi on 2 minus pi on 6. If I now ask you, what is the sine of this complement? Do you see that the sine of this complement is going to be the y value, which is the square root of 3 on 2? So that means the cos of this, square root of 3 on 2, is equal to the sine of this, square root of 3 on 2. And you can see it quite visually here. They're the same length. So that means the cos of theta is equal to the sine of its complement. And of course, the same thing could be said for cos and its complement as well. All right, so that's the thinking behind what we're doing here. So that's the thinking behind it. And you're going to write in these things here in red. And of course, this can now be applied to the second quadrant. So now as we move into the second quadrant, I'm now plussing pi on 2 to it. And so again, the cos of pi on 6 is the square root of 3 on 2. Well, when I plus pi on 2 to it, so when I'm plussing that 90 degrees, yet again, the sine is going to be the square root of 3 on 2. So the cos of theta is equal to sine of pi on 2 plus theta. Also, take note of the fact that if I was to find the sine of pi on 6, it's going to be a half. And now when I plus pi on 2 onto it, I'm now getting negative a half. And the reason for that is because in the second quadrant, my cos is negative. The cos is negative, and therefore I'm changing my cos to a sine, but I now need to make it negative because cosine is negative here. And now we can just apply this logic to the third quadrant. And when I do this, so when I'm plussing that onto it, so 3 pi onto minus theta, so remember 3 pi onto is this line right here, so I'm just minusing theta from it. As you can see, they're both going to be negative this time. So I'm changing the sine to a cosine, the cosine to a sine, and I also have to put those negatives there. And then I could go to my fourth quadrant, same logic again. You just need to make sure that you realize here that sine is negative here, so it's going to be negative cosine, and cos is positive here, so it's going to be positive sine. And that's the thinking behind these complementary properties. We're going to go through a bunch more of examples. So if you're still a bit rusty on this, don't stress. You'll see how this works in some examples, but that's just the background information for what's going on with complementary properties. Hopefully you found this just a good background, but if you're still finding it a bit tricky, don't stress. We're going to go through some examples now.